we're going to do what's called a combined variation today, which is basically taking what we did in our last lesson and kind of putting it together within the same equation. So this is not bad. It's just a little bit weird because you're probably not used to the terminology. So we're going to work with combined variations today, writing them and then seeing if you guys can evaluate them. And we'll set them up from some situations on the back. So just as a little tiny reminder from last time, just what these look like. Y equals k times x is a direct variation, and y equals k over x is an inverse variation. K just is called the constant of variation, and it just represents a number. So in an actual problem, that would be filled in with a number. It wouldn't be another variable. A combined variation, I just kind of wrote this out for you so you wouldn't have to. It's when one quantity varies with respect to two or more quantities. So this is just x and y. This is just x and y. In the combined variation, we'd have like x, y, and z, or x, y, z, and w, or something like that. So there'll be more variables involved in what we're going to do today. And then the last one, a joint variation. This is direct. So it's going to be multiplication with two or more variables. They just call it, they'll say that it varies jointly. That's just going to mean two. It's a direct relationship, but there's going to be two, maybe three, maybe four variables, probably just two or three. So direct variation, multiplication with your k value, but it's going to be more than one variable. Okay, so I'm actually going to do that in this first problem here. So we're just going to translate this. They're going to give us enough information to figure out the k value, which you can't forget to put in these equations. That's the thing that people forget the most. You got to put a k in there when you set this up, and then they're going to ask us a secondary question just like we were doing in the last class. Okay, so this says z varies. So I'm just, z equals. Varies turns into an equal sign. Now, if you see jointly, that just means that the variables that follow that are going to get multiplied together. There's just going to be more than one of them. So don't forget, I'm going to put a k right after that. And then jointly with x and y just means x and y. All of that's going to get multiplied together with your k. Inversely is the only thing that's going to put variables in the bottom of the fraction. So there's not even a fraction here. Okay, now they're going to give us just enough. It says when x is 2, y is 3, z is 60. So just subbing these in. The only thing you won't have is the k. So 60 equals k times x is 2 and y is 3. So we're just subbing this in however you want to do it. And 2 times 3 will just give you 6. So I'm taking 60 as my k value times 6. So what's my k value have to be? 10, right? Just 60 divided by 6. Now, I'm going to back up just real quick here. So the actual equation, after we know the k value, should be z equals 10 times x times y. So you got to find the k value to be able to write that. But if they were like, hey, what's the equation for this, then this would be the equation. Okay, now forgive me, I didn't even read this to you. At the very top, after we set this up, it says find z when x is 4 and y is 9. So we're just going to use that equation we just developed to answer that next part of the question there. So find z, so I don't know z. I know my k value is 10, and it says when x is 4, so you just sub that in for x, y is 9, just sub that in for y, and then grab your calculator. You might be able to do that in your head. That should be 360. It's not terrible. It's just a little weird the way that they're worded. Does anybody have a question at the moment? Okay, see if you guys can do this one. So this one underneath here says z varies directly with x and inversely with y. So I'm going to write z equals. Okay, so if I see inversely, I know there's going to be a fraction involved. So this is directly with x, inversely with y. Don't forget to put the k in with this. Does anybody know how I would write the other side of the equation into an equation versus a description? What do you think? Yes. K times x, that's your direct, over y, that's your inverse. Okay. Then they're just going to give us just enough information to figure out what k is. So it says x is 6, y is 12, z is 15. So I'm going to put 15 in for z. K we don't know. This is what that information is being given to us for. X is 6 and y is 12. However you want to do this, what I did on mine, I did 15 times 12 to get that out of the denominator, and I got 180. And then that's k times 6. And then if you divide 180 by 6, that should just be 30. Now, I'm just going to go back where I started to write this and sub that in. So my actual equation here, this would be z equals 30x over y. All right, and then I'm actually going to use the same thing from here. Just bring this down. So find z when x is 4 and y is 9. So if k is 30, x is 4, and y is 9. We would just figure out what this is. So 30 times this would be 120 over 9. And I'm going to grab my calculator here real quick. That reduces to 40 over 3. Or if you want to do a decimal, this is 13.3 repeating. Does anybody have a question? Okay, I got to have you guys do me a tiny favor on this one here. There's a variable and I didn't give a value for it. So you don't have to rewrite all of this or anything, but just say when w is 8, because I forgot to put a value for w because there's another variable here. And then I'm going to use those same numbers from the top when x is 4, y is 9, and then I'm going to add w is 16. I just totally forgot to put w into that, and it's in the description. It's my fault, so I'm really sorry about that. All right, so I'm going to read this to you real quick. This is kind of a longer one. So it says z varies, so I'm going to write z equals directly with x and inversely with the product of w and y. So directly with x and inversely with the product of w and y. How would you translate that into an equation? Perfect. We just got to put a k in with that. So kx and wy or yw doesn't matter the order you put in. Perfect. Okay, now pretend I didn't screw up and I gave you a value for w here. So z is going to be a half. K is what we're going to figure out. X is going to be 2. Y is going to be 4. And I added this into the directions because I forgot it. W is going to be 8. Okay, so this would be k times 2 over 32. What I did, I multiplied both sides by 32 to get that out of the denominator. If you take that times a half, you get 16. And then if I divide that by 2, you don't have to write out all that work. But your k value then should be 8. So then a general equation, I'm just going to come back over here, should be z equals 8x over w times y. And then I'm using those same numbers from the directions at the very top. It said x was 4, y was 9, but I needed to add a w because I forgot that for this problem. So I'm going to add in that w is 16. So to answer the second part of the question, find z. And I'm going to still use 4 for x, and we're going to use 9 for y and 16 for w. And I don't know why I just wrote k when I know that it's 8. So we'll put that in there. Okay. If you simplify this, you're going to get 32 over 144, and that can be reduced to 2 9. Part of the description. Is anybody having a question? Okay. Now, my second example is going to reverse what we just did, but not quite take as long, because I'm just going to give you the equation and see if you can write the variation in words. All right, so these are all legitimate formulas. There's a couple more on the back. These are all actual formulas. So this is mass of a moving object. You may have seen this in physics. Related to kinetic energy, they use an n, and the velocity, that's the speed of the object. And that's v in the formula here. So I'm going to write this out in a sentence, kind of like what was written above. And you don't have to write out like what the variables stand for if it's an actual formula. So you don't need to write like mass or velocity or anything like that. I'm just going to write M varies because I have M equals. And then, actually, let me ask you this before I write anything else. The K value should not be involved in your description. You did not see any numbers in the description of what I had in the sentences in that previous example. So before I do anything else, can anybody tell me what the K value is just from looking at the equation? What do you think? Just the 2. That should not be part of your description. Okay, so not part of your description. Okay, now 2 is being multiplied by n. So I'm going to say directly with n, which is your kinetic energy, but I'm not writing that word out. I'm just going to use the variable. And then I've got v squared, velocity squared in the bottom. So if it's in the bottom, that has to be inversely with the velocity squared. I'm just going to write v squared. So m varies directly with n, so it's k times n. Inversely with the velocity squared, so the velocity squared should be in the bottom of the fraction. Okay, I'm going to have you guys try the other 2. All right, these are legit formulas. All right, so little geometry throwback here for both of these. So volume of the sphere, 4/3 pi r cubed. Can anybody tell me what the K value is? What is your constant of variation for volume of the sphere? 4/3 is part of it. It includes the pi. Pi is not a variable. I know, that's super tricky. So every time you find the volume of a sphere, you always use 4/3 and pi, so that's your constant of variation. The only thing that's the other variable there is the radius. Okay, now, this is not a joint variation because I don't have multiple variables. I just have 2 numbers, 4/3 and pi. That pi is not a variable, so it's not a joint relationship. This is just a direct. You just have k, which is a little more complicated than some of the other problems we looked at, but it's just k times r cubed. So this is actually just volume, or v, varies directly with radius cubed, or radius to the 3rd, or just r to the 3rd. And that's all you'd have to write. What about, I've got area of a triangle, area equals base times height divided by 2. What would your K value be? Yes, good deal. And you guys know, I'm sure you have seen, sometimes you've seen the area formula written as 1/2 base height. I'm sure you've seen that. Now, this one's a little tricky. So this is what we introduced today, so I'm just going to write this out. But I have 2 variables, the base and the height, being multiplied together. So it's like a direct relationship, but because it involves 2 variables, it is described as jointly. So I would say area, or A, varies jointly with base and height, or B and H. And you could put the B first or the H first. It totally doesn't matter. Okay. Is anybody having a question about translating an equation into kind of a sentence? Okay. Now, the rest of these little bit word problems, you might want your calculator. A couple of these have some weird K values. All right, so I'm going to use just variables in the problem. You can use whatever variables you want. This one says the cost of material used in making a frisbee. So I'm just going to use C for the cost. All right, varies is going to turn into an equal sign. And then it says directly with the square of its diameter. So the diameter, I'll just use D. But the square of that diameter would be diameter squared. And you might be thinking, why didn't we do this in our last lesson? Because we're already doing direct relationship. This is direct. It's considered a combined variation, though, because it's not just directly with the variable. It's because the variable that we're comparing it with is squared. So it is considered a combined variation here. But what we're going to write, just C, your cost. Don't forget your K is what I was trying to say, is your constant of variation times the diameter squared. And we're going to try to figure out what that constant of variation is. Okay, so it says it costs 45 cents. So I'm going to put that in for the cost. And I'm going to use this to figure out my constant of variation. So that's going to be my variable K. For the material of a frisbee with a 9-inch diameter. So the diameter is 9, but we got to square that. So I'm going to do 0.45 is K times 81. Now, if this is me, I know this is going to be like a weird number. So I'm going to just take 0.45, divide that by 81, and I'm getting a gross decimal. And we don't want to round here because that's not as accurate. So just use that little button. I'm just going to do that math, enter, convert it to a fraction real quick. And your K value would be 1 over 180. Okay, so then to do my actual problem, so for any diameter that we know, we can do 180 times that diameter squared to get our cost. Okay, so then it says, what's the cost going to be if the Frisbee has a 12-inch diameter? So we're just going to plug that in. We don't know the cost. So I'm going to do 1 over 180 times the diameter, which is 12 squared, and that would give us the cost for the material. And you can just type that all right in your calculator if you want to. And your cost there is going to be 0.8, so it'd be 80 cents. Anybody have it? Now, this one says the number of bags of grass seed needed to reseed a yard. All right, so that's a lot, but I'm just going to use N for number of bags, okay? Varies directly with the area, so I'll use a capital A for that, to be seeded, and inversely with the weight of the bag. Okay, so for weight of the bag, I'm just going to use W. So I'm going to just try and set up a variation here. So number of bags varies directly with the area, so I'm going to do K, my constant of variation, to represent that, times my area, and inversely means that variable is going on the bottom with the weight of the bag. So I'll just do W for weight. Okay, now the next part of this actually gives you two pieces of information almost right next to each other. So it says it takes 2 3-pound bags. So the number of bags is 2 and the weight of the bags is 3 pounds. And that's going to seed an area of 3,600 square feet. So that's going to be my area. So I'm going to plug all that in so I can figure out K. So 2 bags, K I don't know. The area is 3,600 and the weight of the bag is 3 pounds. Okay, if it's me, I'm just going to multiply both sides by 3 real quick to get that out of the denominator, but I'm going to end up dividing 6 by 3,600. So this is going to be a fraction here for our K value again. And it should be 1 over 600. Okay, now the way this is, because the K value is a fraction, if I plug that back in here, what it would actually look like, you would have basically like 600 times this fraction, or 1 over 600 times this fraction. So on the top, you're not going to see them write in a 1. It would just be A, and then you'd have the 600 times the weight of the bag in the bottom. If you wanted to, you could, but basically the 1 over 600, you wouldn't see the 1 on the top, but it would be kind of implied there, because we're just going to do 1 times the area. Okay, then it says, how many bags? So I don't know the number of bags, but we're going to keep the weight the same. It's how many 3-pound bags, so I'm going to put 3 in for the weight, bless you, on the bottom, if we got to seed 9,000 square feet. So 9,000 is going on the top of that fraction. Okay, now, you can't just type this into your calculator because it'll do 9,000 divided by 600 and then it'll multiply the result by 3. So if you do want, you just have to put parentheses around because you want to divide 9,000 by that product. So I'm going to do 9,000. I'm just going to put parentheses 600 times 3, or you could write 1,800, whatever's easier for you. Just keep that in mind if you're not getting what I'm getting here. You have to find the product on the bottom first before you divide that by 9,000. But it should just be 5 bags. Okay, I'm going to have one more, and then I'll let you guys try some of these on your own. Okay, so the stadium has a seating capacity for 25,000 people to come in. Stadium has 25 exits and can be vacated in 20 minutes. Okay, so they don't start describing the variation in the first sentence at all. That's actually the information we're going to use to figure out K. It says the time taken, so I'm just going to use T for that, to exit the stadium varies, so equals, directly with the number of spectators. So maybe I'll just use N for number of spectators, and inversely with the number of exits. So I'm just going to use X for exits. Determine the time taken for 21,000 people to get out of the stadium if only 15 of the exits are open. So these are, and they have to run these drills in the stadiums to make sure they can, if there's a fire or something like that. So they would have this information. So the time it takes, it says varies directly with the number of spectators. So I'm just going to do K times my number of spectators, and then inversely with the number of exits. I just use X for exits. All right, now, in the original sentence in the problem, it told you about the stadium that it could seat 25,000 people. And let's see, we have 25 exits and it takes 20 minutes to vacate. So 20 minutes would go in for the time. Don't know my K value. There's 25,000 spectators, or that's just the number of people in there. And then 25 exits. So I'm going to do 20 times 25, and then I'm going to divide that by 25,000. I think I put an extra 0 there. Okay, now this is kind of similar to that last problem. The K value would be 1 over 50. So if I was plugging this into the formula that I started to write out here, like a general skeleton for this, it would look like your number of spectators over 50 times the number of exits. The 1 would not be written in the top. It would be kind of implied. Okay, so then we want to figure out our situation. 21,000 people. We're going to figure out the time here. So 21,000. And then 1 over 50 is our K value, but 50 is going to be in the denominator. And then they say there's only 15 functional exits. This is also similar to the last problem. You would want to figure out this product first before you do the division. So I'm going to do 21,000 and then just put parentheses around it or figure out what it is. But then the time here, and since the original time was in minutes, that's what our answer will be, 28 minutes. Okay. Is anybody having a question? Homework is really similar to this. It's going to say 9-2. It should just be the second page in the homework packet. And then if anybody